Welcome to 24 Hours of Pass SQL Server 2014 edition. We're excited you could join us today for Alexi Halyako's session on Ask Me Anything, Open Questions on SQL Server 2014, Microsoft Azure, and Big Data. This 24 Hours of Pass event consists of 24 consecutive live webcasts. The recordings of these sessions will be available next week at 24hoursofpass.com. My name is Jennifer Mosier. I'm a Product Marketing Manager at Microsoft, supporting SQL Server and BI communities, and I sit on the PASS Board of Directors. Now before we start this Ask Me Anything session, I have a few introduction slides to go over that will help you participate in submitting questions for our speaker. Firstly, at any time, if you're having any issues, just raise your hand by clicking on the hand icon on the right side of your screen, and someone will assist you. To maximize your screen, use the Zoom button located at the top of the presentation window. As all attendees are muted, you will need to submit questions for Alexi via the Questions pane on the right side of your screen. When we open the floor for questions, I will read them aloud for our speaker to answer. If there are a series of similar questions, I may group them together. Note that there will be a short evaluation at the end of the session, as your feedback is important to us, so please take a moment to complete it. It will show up automatically on your screen as you leave the webinar. Click. While it feels odd for me to thank Microsoft, I would like to acknowledge that without sponsors like my employer, staging events like 24 Hours of Pass would not be possible. Next, I'd like to bring your attention to the upcoming PASS Summit, taking place in Seattle, Washington from November 4th to the 7th. PASS Summit will feature over 190 sessions with world-class SQL Server experts. The planned and presented by the SQL Server community for the SQL Server and BI community, the PASS Summit is single-handedly the largest gathering of SQL Server and BI professionals. With over 5,000 attendees from all over the world, PASS Summit is also a great place to network and meet face-to-face with experts, peers, and MVPs. More importantly, PASS Summit delivers on providing you with the answers for your SQL Server and BI issues, along with the knowledge, strategies, and skills you need to stay ahead of the curve. Contact your local chapter for a discount code to save $150. And to save even more money and optimize your savings by registering before this Friday, June 27th. And find out more about PASS Summit, visit passsummit.com. Click. And now a little bit about our speaker, or rather our answerer today. Alexi Halyako has been with Microsoft for over 10 years. He's been working on the SQL Server team collecting globalization requirements for SQL Server 2005. Alexi is also a member of the Azure Cat European team and has been there for 4 years. And now, see if we have any questions, which we do not. Perhaps, Alexi, you can start us off with a few commonly asked questions that you see from customers and others.
Yeah, hello everyone. And one of the typical questions what we get working with customers, and like as Jennifer already introduced, I work in the EMEA part of the Azure advisory team focusing on analytics end-to-end, so which includes a lot of components where a lot of data gets gathered and analyzed, and people asking like what SQL Server 2014, for example, will have in common, say, with cloud and big data. And to address this, we need to look at what SQL functionality supports in a sense like to be a part of the big data solutions. First of all, in order to connect SQL database or to expand the workload, like for example, spend the compute power in the cloud, SQL Server got a number of functionalities which seamlessly integrate cloud technologies with this database. And I have another question, like out of top 10s, covering a little bit this. Then if you look at the on-premise configuration, the largest appliance what represents SQL database is Parallel Data Warehouse. It has technology called Polybase, and it integrates very easily Hadoop backends, both on-premise and the cloud, to the PDW workload. So basically you can access the data stored in the cloud or expand your queries on the PDW to Hadoop distribution and get benefits of the both parallel query execution engines. Then, of course, another thing is since cloud offers you a lot of highly available, nearly all-time accessible data spaces, one of the very interesting things what SQL Server 2014 gets is ability to back up your workload, back up your data into the blob storage. So this is can be used in scenarios, for example, when you need to archive massive amounts of data and you don't want to invest into storage, like physically placing somewhere big racks with a lot of data space and pay for this. You can rather much cheaper subscribe to Azure and place your data there. So are there any questions so far, or we can move ahead?
This is Jennifer. We don't have any questions so far, but as we're just starting to get some more attendees joining us this morning, I'd like to take a moment to explain the format of this session and how it differs from others. Typically in a 24 hours of past session, we have 40 to 45 minutes of speaker or speakers doing a presentation, followed by 20 to 25 minutes of Q&A. In this different format of Ask Me Anything that I first found out about through Reddit is really an open discussion opportunity with a limited, if any, prepared presentation. And really it's driven by the attendees. So I'd like to encourage everyone who is on the call to throw out any of your questions, whether you think they might be obvious or really complex, and we'll answer them as we can. So as that goes, I still don't have any questions in the queue yet. Perhaps people are waking up over there in Europe and need another espresso. Perhaps, Alexi, you can speak to some of the other common questions that you get.
Yeah, so the next common questions, how can I leverage cloud for my existing SQL workloads? And there are several ways of how can you utilize cloud capabilities and binding them, let's say, to the existing infrastructure. One of the very obvious scenarios what a lot of especially enterprise customers considering and really deploying at the moment, and I think there was a lot of discussions around that in previous sessions in this 24 hours pass event, and this is about moving parts of the databases or moving parts of the virtual machines into Azure using Windows Azure VMs, or another way it's called Information as a Services VM. The story what we observe often, a lot of companies invested tons of money in consolidating their environments, therefore they host multiple smaller size virtual machines with little database, departmental level databases on their huge host machines. And one of the benefits of the cloud, you can easily import those virtual machines into the cloud for this non-critical databases and actually save the cost of hosting huge hardware on site. So, and in this way, you also offload some of the workloads from your on-premise configuration in the cloud. Then it requires some of the using technologies which expanding your domain, for example, to the cloud. We can talk about that later if it's interesting. I think if people heard of this, we can skip this. One of the another interesting investments what SQL Server did as well is imagine you have a massive data warehouse, and typical scenario what we see working in the data warehouse environments, you split typically, or you can characterize your data in three main buckets. One bucket is extremely hot data, where the data just ingestion and then they are frequently updated. Those are like this information is about like what currently changes with regards to your customer information, with regards of your stock information, and etc. And there is a bunch of information which stored in like semi hot format, like this is the information about what happened to your customer yesterday or week before, depends on like how you utilize your data. And there is a bucket which called archive data. So all these three layers require often different types of the storage. Like for hot data, you want to have something very quick with low latency, like SSD drives, for example, or Fusion I/O drives, any kind of these in-memory technologies. And then for like semi-hot data, you can leverage data from, you can leverage storage from like SATA, SANs, or whatever. And for archive, which you often don't really even look at, you just need to preserve data depending on like some legal legal restriction or something. You need to have cheap storage where you can quickly access. So SQL Server 2014 allows you to put your or create your file group right on top of the Azure storage. So basically you connect your database and your database will transparently access blob. Of course, this information will have high latency when accessing, but from another side, it's very cheap, and if the data are not accessed often, then the SLAs may be met anyway. So I see we've got a question.
Yes, we have Matt Penny, who asks whether or not you've got a feel for the portion of SQL data that's currently stored in the cloud versus on-premise.
So there I will try to rephrase this question because there is a number of scenarios where the SQL data might be stored in the cloud. First is a hybrid solution where, as I mentioned already, people trying to expand their existing environment to the cloud and leveraging compute and storage power of the cloud. And there are also scenarios what we already worked on where people create solutions from scratch in the cloud, and therefore their SQL data, they get, so to say, born in the cloud already, and they exist only in the cloud. They are never moved into on-premise configuration. So therefore, if you look at the hybrid solutions, it really depends, but like from experience, what I have, we work with both SQL Azure database, which is different from storing data in Azure VMs, but still it's like it really depends, first of all, on type of the data, and second on how the data will be used. We worked with, for example, one of the customers where a lot of merchandisers, mobile merchandisers, were trying to, the demand was to access CRM data for particular users and as fast as possible from any location in the world. Therefore, the CRM was uploading the bunch of information, even historical information, into the cloud, and the proportion was like, I would say, 70% or 65% of the data in the existing CRM were copied into the cloud. In some other hybrid solution, it's like 80 to 20, where historical data offloaded, the historical data stored in classical on-premise data warehouse, and the only like most current information is shared with people, and this sharing information happens also in the cloud. But there are also other solutions, and we talk also not only about SQL but the Hadoop technologies, where the proportion may look completely opposite, where 80% of the data stored in the cloud because data coming from outside, and just little pieces may be synchronized with data on-premise. So therefore, like if you speak on the worldwide experience, it's really hard to measure. It really depends on the workload type and type of the business. Does it answer the question?
Sounds good to me. I'm sure Matt will respond with another question if we missed something. But on a related note, before I go to the next question, I noticed in your bio that you worked on SQL Server 2005, collecting the globalization requirements for that. And I'm really wondering, I want to ask you a question about that. I know that from my experience in working with the community, there's a lot of SQL Server 2005 servers out there running on Windows Server 2003. And people are starting to think about end of life for those applications running on those systems. And I'm wondering if you're hearing anything from customers about migration scenarios where they're reconsidering their architecture for their applications and thinking more about leveraging the cloud or hybrid scenarios.
It's an interesting question, because I can tell you I probably might be the wrong person to answer this. Like, speaking of the nature of our engagements, we are trying to work with cutting-edge technologies. Therefore, often when customer comes to us, they have idea, they have demand, but they don't have legacy too much, and therefore the migration questions are not coming too often. And yeah, however, we also dealt with a couple of the projects in the past, like before switching completely in the Azure environment, where people were trying to create consolidated environment or consolidating databases in the massive data warehouses, and therefore 2005 was really a question, and how do I migrate my data into new technologies, and what the benefits the new technology give me. And addressing this, there's like, especially after release of the 2008, although the 2005 was like revolutionary versus the 2000 release, right? So in 2008 we've got way more like a lot more improvements with regards to the high-end workloads, like high-end OLTP or high-end data warehousing, and 2014 added even more functionality in this direction, like, for example, statistics for partition tables improvement, and clustered column store indices, basically moving bunches of your data into the memory instead of trying to leverage the classical I/O patterns. And this significantly expands the possibility of those high-end solutions, like the data warehousing become more scalable and much faster. And the integration with cloud is also significant. One of the scenarios what we see is a lot of smaller size data warehousing, like not critical, like speaking, for example, of HR data warehouses or accounting data warehouses. They are like really often under few 100 gigabyte size. They benefit from moving into the Azure because the cost of ownership of the VM in the cloud often way cheaper rather than maintaining the same configuration in on-premise world, like cost of the hardware, cost of the administrator, cost of the operational effort for this administrator, like backing up databases, like checking the health, and etc. A lot of this stuff happens in the cloud automatically. Like if you move your data into SQL Azure database, you don't really need to pay attention to backup anymore because it's highly redundant. And I mean, under the hood, we maintain at least 3 copies of your database, so therefore you don't pay attention to backup anymore. The only backup what you may think of if you do some changes, critical changes in your database, and you want to preserve 2 versions somehow to be able to roll back, but in fact, like in terms of high availability, this is not your problem anymore. You don't need to think of clustering, you don't need to think of maintaining regular backup and thinking like how to develop all this backup strategy and etc. So therefore, cloud gives a lot of release on the traditional administrator operations, depending on which technology you choose, like VMs or SQL Azure database. It might be different, but it's still way less effort rather than on-premise world. Make sense?
I'll answer for everyone. Yes. We are starting to have a few questions come in. Seems like we have one on security, one on licensing, and another question on ETL process. Which one do you want to go for first?
With regards of license, I can tell in advance I'm not an expert on the licensing. The only thing what I know for licensing, especially in the hybrid environment, and you could read probably question first because I don't see it too much. The window is pretty much small here. Jennifer?
Yes, I'm sorry.
Could you read please the licensing question?
The license, so Marion wants to know what are the licensing implications for having a database in a hybrid way?
So if you, I think it would be easier to answer following that. If you plan to put some VMs in the cloud and so use the hybrid scenario, you can choose the Microsoft image. So basically then you pay for the model called pay as you go. So as long as VM is running, you're paying. If it's shut down, you're not paying. And if this is like 24/7 workload, requires to be online all the time, so it might be cheaper to look at the option where you buy the licenses the same way as you buy it for classic on-premise configuration, and you apply this license for those VMs in the cloud. So it's kind of very similar to existing in on-premise world. For the more information, I would rather refer to the documentation in the cloud because, like, this is more or less all what I know about licenses. Now, the ETL question. With regards to licensing, okay, Marion, I will refer you. What kind of benefits? Oh, just one moment, Alexei. I do want to follow up with your response with regards to licensing. Ask Me Anything series earlier today with Scott Klein, Bill Kahn, and Bill Gibson and Joanne Marone, where they spoke to a lot of the licensing and the cost questions. So I'll encourage you to take a look at the recorded sessions once it goes live next week. But the next question you wanted to speak to was with regards to the ETL process. Joseph wants to know what kinds of benefits the ETL process can get from SQL Azure. Here I need to clarify a little bit the question. If we talk about existing ETL and it is based like on known tools like SSIS, for example, Informatica, or whatever, So and then if you can expand your ETL, if the question about like how can you leverage ETL to connect your workloads to the cloud. In this case, I delivered a couple of sessions back like some months ago on building or expanding your workload, ETL workloads to the cloud, so adding cloud to existing ETL process. And the great thing about that, doesn't matter if you work with SQL Azure Database or Azure VM, it doesn't require too much of the rework. You add just cloud-based data source to your workflow, the rest stays the same. However, in few words, what you need to pay attention is cloud is like multi-tenant environment first, and second, it is not your private infrastructure anymore. So the network bandwidth is not as predictable as if you work in a classical on-premise world. So therefore, what you need to pay attention to is there are a bunch of approaches and documentation around how do you react to the situations if, for whatever reason, your ETL process failed. Like, for example, you start loading data into the cloud database, and for whatever reason, so like your network provider just decided what you don't need to work with internet anymore, he shuts down the entire infrastructure, so the network connection is not there anymore. So how do you react? So how do you, you need to put some retry logic, and there are a few tricks what they can do about that. Basically, there are components what the CAT team developed, and you can find them on the Codeplex, and those components helping you to build the retry logic into your ETL package. Another thing what you need to pay attention is scalability of the ETL process. But typically, like all high-end ETL processes on premises, they have some notion of how you scale the loading data out of your flat files, some multi-streaming, running multiple packages and writing into database in multiple streams. And the same approach you use for the cloud environment. Just only difference is the retry. How do you make sure what the package will restart if some failure happened on the cloud side? Like you get throttled, you lost the network connection or whatever. Make sense? Did it answer?
Well, I won't hear otherwise. We have some more questions coming in, I'm happy to say. Mm-hmm. Let's go with Anil's question about data security and data violation when they store data in the cloud or Azure. Maybe you can, you have some, core information to share around security.
Yeah, so security, this is a very good question because often we run into discussion, especially I'm presenting out of Germany, and Germans are extremely sensitive around with regards of what happened to my data if I put it in a public environment. Like there are some very interesting and restrictive regulations around like the data must not leave the geographical border of the service company, and et cetera, et cetera. One of the things what we need to pay attention, talking about security, first of all, is Microsoft certifies and continues to work on certifying our Azure infrastructure with the most critical and most known security standards. And we have a list of the certifications which is bigger than any other company can offer. What does it mean for us? What we are not only certifying this, but we also live those certifications. So all the internal infrastructure, it complies with all these requirements. So it means what the data stored in secure way, it regulates how you access the data, and etc. So this is first thing. Second thing is really about how do you secure your data in your infrastructure now. Like, do you use encryption when you're storing data? How do you store your backups? Who can connect to your database and etc. And the same approach applies if you move your data to the cloud. Like if you have sensitive information, there's a bunch of technologies out of the box what SQL Server offers and Windows offers in order to restrict access to your data. Same if you want to store, well, if you run Windows Azure VM, on background, these VMs, they have blob storage where your data will be stored. When granting access to the blob storage, you also have at least three levels of security, whether you make your data private or public, right? And this is on top of the security what you can use in SQL Server, like encrypting data. You can expand your Active Directory to the cloud, so therefore only people from inside of the Active Directory will be able to talk to your Azure service, and etc. and etc. So there's a bunch of things which you can do for security. One of the other things what we also had successfully implemented, and a lot of people talking about that, if you want to offload your workloads into the cloud, you also may apply the trick, but for some of the calculations, you don't really need to move the customer-related sensitive information in the cloud. One of the examples is one of the very often scenarios where we see people working with the cloud is using big data technologies as a compute for predictive analytics. Predictive analytics is it is about, like, I have number of products and I have number of customers who like particular product, right? Can I, if you follow a particular pattern, can I recommend you what would be your next choice based on experience I collected from the previous product purchases by other customers? So this is typically, you look for relationship between product SKUs and the customer's behavior. In order to calculate the similarity matrices, you don't need to load customer address information, customer name, customer bank account number into the cloud to compute the similarity matrix. You need probably customer ID, which could be any kind of not very transparent for the people from outside key, and you need SKU key, so like product SKU or whatever, product ID number in order to build the similarity matrix. So in fact, you're working with anonymous information which can generate a matrix, and this matrix will help you run your recommendation engine. So there's multiple of number of tricks which can allow you to use compute power in the cloud without without kind of forcing you to not comply with security requirements. So I hope this is this answers the questions.
So it certainly was it sounded like a pretty thorough response to me. We have.
Well, this is pretty much big question in the cloud, and especially like considering what it's open, it's public, and what level of how far should you go in order to leverage compute on top of your customer-related information, the sensitive information. Yeah.
Yeah, absolutely. Definitely a hot topic, if not the hottest topic.
Yeah.
We actually have Anil from Nepal and joining us today, or this morning, or this afternoon. I'm not quite sure what time it is in Nepal. But he asks, his question, I'm not quite sure if I understand it, so I'll read it to you and you let me know. And perhaps he can ask any sort of refining questions as a follow-up. But he asks, he says, the SQL Server operating system allows one active thread per scheduler. What's the case with in-memory OLTP in SQL Server 2014? And then he goes on to ask why SQL Server creates only one scheduler per logical CPU, and then why can't we think of active multi-thread per schedule in order to gain performance?
I'm not sure I understand. I'm not sure I understand the question as well. So basically, I think it's quite clear, but we can have only one active scheduler. So basically, core computing something related to particular task, right? And what happens, like from general understanding how the SQL Server Operation System works, you may have a situation where the active task may be in two phases, or actually in three phases, right? First phase is when it's actively executed, the rest will be queued and waiting. The second, in case if we think what we can get access to, well, if you need to get access to some extra data to process further, and we think it will happen fast, so we keep the task kind of active. We don't pass the thread to another task because we think we can come back and start computing further another time. Like good example here, if you need a portion of data to read from I/O and we think we can read it quickly because it's in buffer or something in order to keep the task processing. So then the task will not release the scheduler, and the third phase is being queued, right? Just waiting for getting the scheduler, or when we say, okay, it will take too long, we will put the task again in the wait list and give the scheduler to another one. So basically the principle here, you can process one active thread at the moment, and the logical CPU is actually something different from the physical. I mean, logical core is something different from the physical core. Is when the in simple words, when we see what the physical core is underutilized, we can share on the physical level the cycles of the same core between two tasks. Like one, when it's waiting, we say, okay, it doesn't make sense to wait until the task can process further. We give the cycles to another one. It's like cached but not really active, and another one can get executed. So when processor is underutilized, this is how we present this logical cores. So it's not physical thread, it's kind of visualized thread. This is how I understand how it works. So therefore, it is already, hyper-threading is one of the technologies which speeds up the processing of the threads significantly. There was discussion, nice discussion around about like what do you do if your threads are extremely busy, like high scale OLTP processing, where you see what the core, physical core is extremely busy. In this situation, there's a white paper which says even like you can recommend switching off hyper-threading to get benefit from the physical core performance. So therefore, I'm not really sure I understand the question. So there's a lot of kind of what happens on the background which supports already sharing the physical scheduler between the tasks, and maybe some like additional points to what exactly is interesting may help to answer this question better.
Okay. Actually, for the next question, I'm wondering, Alexei, if you could actually review one of the more common questions that you get in that you see around Azure Database or Azure and SQL in the cloud.
Yeah, I see we've got one question from Rafi not answered.
Well, Rafi, I think he was more, Rafi says Microsoft was, yeah, I think Rafi was commenting on the licensing conversation that we had earlier, highlighting the fact that Microsoft only chart with either SQL in an Azure VM or Azure SQL Database. Microsoft only charges by the minute. You can install your own licensed SQL Server licenses, your on-prem licenses in a VM, or you can provision a VM with an image of SQL Server. So you do have those options.
That's correct. Yeah.
Which is great.
Then, yeah, absolutely, great comment. Since there are no other questions coming, and this session is about big data, I want to switch a little bit different from SQL Server subject and talk about big data solutions and what is the real big data. And in fact, Microsoft positions as big data not only Hadoop distributions but also like PDW and data warehousing, because the big data is the way how do you treat a lot of data would come into your infrastructure, right? And when we talk about big data, one thing in common, what I see in different patterns, in different projects, is the big data problem is not really about I have a small data warehouse and it doesn't perform, so maybe I should switch to Hadoop. It is really about when you need to ingest a lot of data, and we're speaking of the terabytes range. One of my friends, he said basically, if your deviation of the data per day is in the range of terabytes, then you definitely have a big data problem. Often we start hearing discussion on the big data when people have some classical relational data warehouse problem and they don't know how to address this thing, and they desperately hope what the Hadoop will answer this question. And often it leads to some frustration because people do not achieve those they cannot address these problems by moving to Hadoop. But still, if we talk about platform choices, Microsoft offers now many different platforms, many different tools that they can use in order to build big data solution. First of all is classical SQL Server data warehouse in the cloud, for example, or on-premise. With regards of the data warehouse in the cloud, we looked at the fast track reference guide, which was published back in, I don't remember, 2008, probably 2009, first version, and this is the document based on the Experience SQL Customer Advisory team where I was part of, collected, and it collected all the experiences we saw or gathered in different data warehousing projects, and came out with balanced architecture where the CPU power, memory utilization, network, and the disk performance were kind of balanced in order to give you best performance. The same approach we use for creating data warehouses in the cloud as well. So you can go and choose either pre-built for you image in a gallery, and it's called SQL Server for Data Warehousing, or you can go and follow the white paper, which is also available, and build your own solution based on the cloud VMs, and this would be your cloud version of the big data based on the database technology. Another thing is you also can use Hadoop, and there are two ways how you can leverage Hadoop distributions in the cloud. One of them is platform as a service, or another way it's called HDInsight cluster. And this is typical PaaS platform. PaaS means you do not really care about how it's built inside. It is a service. You can deploy this service and you can leverage it for running computations. But the amount of insights from how the infrastructure, how the cluster is built, is really restricted. However, this is very good tool for ad hoc, typical Hadoop workloads, right? If you need to have more granular control over your Hadoop server and you have specific requirements for running workload on Hadoop, you can go and choose IaaS VMs with Hadoop distribution. You can build it based on Windows and use, for example, HTTP distribution of the Hadoop cluster, which works on Windows. or you can go and build also Linux clusters with Hadoop clusters like Cloudera, for example, on top of that. And this will help you move your workload in the cloud. One of the advantages of why would you want to move your big data workload in the cloud is cheap and scalable storage. PaaS, and this is like one of the, I think, next top questions which we collected, is PaaS is classical or canonical Hadoop cluster running in Azure, but contrary to classical Hadoop distribution, it focuses not on the HDFS storage, rather on WSB, which is Windows Azure storage, right? And PaaS allows you to connect nearly unlimited storage space based on the Windows Azure blob storage. And so the biggest project so far, what I was working on, was deploying about 70 node clusters in the cloud to run and compute the workloads. It's actually mostly related to predictive analytics and calculating similarity matrices for the user behaviors on the particular website. The thing what people need to pay attention, PaaS is mostly interesting when you need to build on-demand compute cluster. So it's not really what you would want to run it 24/7. It's like you've got the workload where you, for example, load the data in the blob storage. There's some process running on top of this data, like to clean it or to prepare a particular view what you may want, and then you say like once a day I need to run particular script which will compute the output for me, and it runs like a couple of hours a day and the rest of the day you don't use it. So this is the scenario where HDInsight is really great fit. And if you say what you need to run the workload, which, yeah, this is also a very interesting topic. Since you don't have too much of control what happens under the hood of HDInsight, often it can work with most of the big data workloads. It supports most of the open technologies, like, for example, compressing data, running custom MapReduce algorithms, and etc. One of the things, though, if, for example, you need to migrate existing on-premise solution into the cloud, which utilizes a lot of the open source IP, then you may need to look into the IaaS option, because this migration will be done easier, and the same tooling and the same distribution of the cloud will, of the Hadoop cluster will be available for you in the cloud. So a little bit about other big data alternatives, not SQL based. Anything we've got yet?
Actually, Roman asks a related question. He wants to know what brings HBase to the new HDInsight version and versus Hive, question mark?
So the HBase is an attempt, well, the classical Hadoop server is designed for a particular workload, and this particular workload means it's close to the classical data warehouse. It's kind of scan-related workload. If you look for the pinpoint queries, like for looking up for the single row and etc., there you need to have a little bit more of the classical relational database, and this is what the HBase does for you. So the HBase runs not really on top of the Hadoop data, it runs on the side. It can connect to the Hadoop to retrieve some data, but for pinpoint queries, HBase is better designed, and it also supports like a classical relational engine, all the indices and etc. This is what simplifies accessing particular row if you need, right? The one of the advantages of the what makes HBase be a great partner of Hadoop, it can scale the same like Hadoop clusters, so you can create multi-node HBase cluster. But don't really think of it as something running on Hadoop. It is rather a partner. It sits like on the same. It may sit on the same cluster. It may be configured separately. And as I said, think of it like relational, non-relational engine.
Looks like we don't have any more questions. Did you have any more common things? If not, I have a couple of thoughts.
Let me see quickly what I have. Well, I have one more note on Linux, and actually it's also interesting discussion regarding provisioning big data solution to the cloud, comparing it to HDInsight. So one of the key differentiators for PaaS and for Hadoop based on Windows or on Linux VMs in the cloud is how do you deploy the solution, because HDInsight is greatly designed to be, like as I said already, on-demand compute powers. So therefore you will be probably using scripts to deploy the cluster and to run workload and etc. So since it is PaaS service, you in the scripts you just define the scale of the cluster, just a couple of parameters in your configuration script, and it will be all created on the background for you. In case if you deploy Hadoop cluster on IIS, you need to run basically deployment of each of the cluster nodes. You need to create a script which will be deploying each of the cluster nodes yourself. So this ends up in pretty much massive and big script and complex script. However, we have a couple of colleagues from the CAT team. They worked on preparing distributions of the Cloudera and HTTP in the cloud, and they published some of this information in the GitHub, so you don't need to create it from scratch. You can refer to publicly available information. But the point is IIS versus PaaS, simple script with few parameters and easier to manage versus a very complex environment what you need to deploy yourself. One of the things what you may say here is what if you deploy it in VMs, you probably need this deployment script once, which can be true. So therefore, you create this script, complex script one time, and then don't really waste a lot of time on deploying it multiple times. You're just focusing on operational side of the cluster. True, but also the thing is you will need them working in the cloud environment, and this is related also to the other hybrid solution and etc. One of the things what you need to keep in mind, how do you control your environment? Like if you speak of the cluster configuration like 70 nodes and higher, often it is very problematic to look and into each of the nodes and understand the health of this system. So therefore, what you need to pay attention is how do you collect the information around telemetry of your solution. And we have a documentation published on the framework for building telemetry solutions around the cloud to monitor and control operational stage of your cloud solutions. And like if you look at the cases like Pottermore, for example, Blindbox and Sochi Olympic Web Games, where we deployed hundreds of virtual machines in the cloud or virtual services in the cloud, this framework helps you collecting aggregated information of health of each of the individual VMs and drill down to the VMs and see the statistics of what's running there, what problem this VM has, and etc. in order to proactively react to the failures without waiting until customers will start complaining about that. This is one of the things which is relevant to overall cloud applications running. Running applications in the cloud. You need to pay attention to how do you monitor these massively scalable solutions. So Jennifer, you had the ideas.
Well, we actually have 6 minutes left in the call. I would like to give the participants one last moment to submit questions. Otherwise, I thought it might be interesting for you to speak to one of the topics that we had discussed in one of the previous 24 hours of hot sessions, and that's about using Azure for HA and DR, the high availability and disaster recovery. Perhaps you could speak to some scenarios you've seen with customers, or some trends that you're seeing, or just the experience that you've had, or best practices you want to share.
Yeah, so we have referred then to the existing technology in SQL Server which called Always On. And Always On allows you to, the like basic principle of it, Always On allows you to create readable replicas of your database somewhere else, right? And if you look at the hybrid scenarios especially, right, it's often can be interesting when you, for example, can offload some of the reporting workloads into the cloud and make it available for a number of maybe customers outside of your company, and do it very cheap based on the cost of the Azure resources. So, and therefore, if you do hybrid solution, one of the best practices what you need to pay attention is Always On requires cluster configuration. It's asymmetric, but still cluster configuration between two VMs, and for that you need to keep in mind you need to configure site-to-site configuration, basically expand your internal infrastructure to the cloud. And this is easy to configure, by the way. The only thing what you need to pay attention is what the hardware has to be has to be presented in a list of not really approved, but designed for making this tunneling to the cloud. Right, so one of the recent updates, what happened with the cloud infrastructure, before we were bound to the internal VNet, and this is one of the best practice talking about like creating always-on configuration either in hybrid or pure cloud environment, because we had cases when people created a SQL cluster in cloud-only environment, and still you need to set up VNet, so virtual network, between where all these machines will be running. And previously, the restriction was what this VNet, you couldn't cross the border. One of the challenges we had in one of the projects was customer required geographically supporting geographic disaster recovery things. So if one data center dies, so what the workload keeps running then on another data center, and before that recent change in the cloud environment, it was not possible. Right now we allow also to expand virtual networks to different data centers, so to different geographical data centers. So therefore you can build your always-on configuration across multiple data centers. And this is very great option, especially is like if you build environments similar to Sochi website, where you also want not only to have HA and DR configuration across multiple VNets, but you can distribute your workload, I mean reporting, so read queries across number of geographies, like Americans will access American servers in American data center and US data center. Europeans will access the data centers out of Europe, and Asia data centers in Asia. So this expansion of the VNet to different geographies simplified the configuration a lot. Now, speaking of the best practices, it's pretty much well documented, everything, and if you're familiar with always on in on-premise, it's really not that different, not much different in configuration. So I would say it's really, I'm not sure if it's no-brainer, but it's something what easy to set up and maintain. Do you have any particular aspect of this question what you need to highlight, Jennifer?
No. I think you answered my questions, so you can feel good in that. We had for this AMA session, we had some interesting questions from attendees who clearly are joining us from around the globe at this call, and I would like to take a moment as we close this call and thank you, Alexi, for joining us today, and appreciate the insights that you give us, coming from your office in Unterschleißheim. And I would like to thank all of the attendees who participated and those who listened and hopefully got some interesting and helpful insights from some of these questions and topics that we've discussed. As we said earlier, this recording will be available next week, and I encourage you to take a look at some of the other recordings of the 24 Hours of Past session. And with that, I'd like to thank you for your time and close this session.
Thank you for inviting, and thank you for questions, guys.
Thank you, everyone. Have a good day. I think everyone's starting their day. So thank you very much, and goodbye.